Good morning, children. Today we are going to discuss Unit 5 of Basic Science textbook, Measurements and Units. You are all familiar with many measurements like time, distance, temperature, etc. The first measurement we are going to discuss is length. If you are asked to measure the length of a table, you can use any of these objects in this picture. But the problem is, each one of you will get a different measurement. Is it acceptable? No. So we need a standard unit so that all of you will get the same measurement. The basic unit of length is meter. It is denoted as small m. Is the unit meter sufficient to measure all lengths? There are many measurements of length which are smaller than meter. So what do we need? We need smaller units of length, right? These are some of the tools that are used to measure length. We use smaller units of length in here. See these meter scales. We can see that 1 meter is further divided into small equal parts. In that, centimeter is 1 by 100th of a meter. 1 centimeter is further divided into 10 equal parts. The length of each part is 1 millimeter. That is, 1 millimeter is 1 by 1000th of a meter. Like this, there are units of length or distance which are greater than meter. Let's familiarize with some units of length other than meter. Kilometer is 1 unit of length which is equal to 1000 meters or 10 raised to 3 meters. As we have already seen, 1 centimeter is equal to 1 by 100th of a meter or 10 raised to minus 2 meter. Like that, 1 millimeter is 10 raised to minus 3 meter. 1 micrometer is 1 by 10 raised to 6 meter or 10 raised to minus 6 meter. Like that, 1 nanometer is 1 by 10 raised to 9 meter or 10 raised to minus 9 meter. If we have to convert any of these measurements into meter, we just have to multiply the measurement with these values. For example, if we have to convert a value in micrometer to meter, we just have to multiply that value with 10 raised to minus 6. And if we have to convert a value from meter to micrometer, we have to multiply it with 10 raised to 6. Now let's see some of the units which are used to measure the distance to planets or stars. Astronomical unit is one such unit. One astronomical unit is the average distance from the Earth to the Sun. It's approximately equal to 15 crore kilometers. 1 light year is the distance traveled by light in 1 year. In vacuum, light travels 3 lakh kilometers in 1 second. Now, 1 parallaxic second or parsec is equal to 3.26 light year. Now let's move on to the measurement of mass. You all are familiar with this apparatus. It's a common balance and the weight blocks that are used to balance it. Common balance is the apparatus that is used to measure mass. You know that mass of a substance is the measure of the quantity of matter contained in it. The basic unit of mass is kilogram. Its symbol is kg. There are many other units that are used to measure mass. Some of them are given here. 1 milligram is 1 by 10 raised to 6 kilogram or 10 raised to minus 6 kilogram. 1 gram is 1 by 10 raised to 3 kilogram or 10 raised to minus 3 kilogram. Two other units that are greater than kilogram are given too. 1 quintal is 100 kilogram or 10 raised to 2 kilogram, and 1 ton is 1000 kilogram or 10 raised to 3 kilogram. We can convert these units into each other just like we did in the case of length. Now let's see the measurement of time. The basic unit of time is second, and it's denoted as small s. We know that 60 seconds combine to form 1 minute and 60 minutes combine to form 1 hour, and 1 day consists of 24 hours. So 1 second is 1 by 86,400 part of an average solar day. Now we have seen length, mass and time. These are all examples of fundamental quantities, and fundamental quantities are those quantities which are not related to one another and cannot be expressed using other quantities. That is, fundamental quantities are the basis of all measurements. The units of the fundamental quantities are the fundamental units, and the system based on these fundamental units is the International System of Units or SI units. In SI units, in addition to length, mass and time, we also consider electric current, temperature, amount of substance and luminous intensity as fundamental quantities. There are many measurements which use units other than fundamental units. Units which are expressed in terms of fundamental units or those units which are dependent on fundamental units are derived units. Density is one such measurement which uses a derived unit. Density is given as mass by volume. Its unit is kilogram by meter cube. That's unit of mass divided by unit of volume. That is, if two substances of same mass is given, its density will depend only on the volume. The substance with larger volume will have a smaller density. And if there are two objects with the same size, then its density will only depend on the mass. The object with larger mass will have larger density. You might have seen objects floating on other objects. Objects with smaller density will float when placed in a liquid of higher density. That is why kerosene floats when it's placed in water. And in the case of liquid soap, water floats above it. It's because of density that an egg floats in salt water and sinks in fresh water. Salt water is more dense than egg and fresh water is less dense than egg. It is because of the higher density of salt water that people can float in Dead Sea. The amount of salt in Dead Sea is very high. So the water of Dead Sea is very dense. I hope you have all understood the topics. Thank you.